Bismillahirrahmanirrahim. Students, continuing with the topic that we started in the previous lecture, that is mathematical induction. In the previous lecture, we had a concept regarding that what is induction, and we also solved a question against it, and we proved that statement with the help of induction. Today, we are going to solve some more questions. Starting with the first question, let's say we have 2 plus 4 plus 8 up to 2 raised to the power n, which is in fact equals to 2 times 2 power n minus 1. We have to check the validity of this statement with the help of a method that is called induction. Now let's start with the base case. And here I am taking the first value of n, that is equals to 1. As you can see in the series, the first term, that is 2, how is that obtained? Because the series is going to have a pattern that every term is in fact 2 power n. So this is in fact 2 power 1, second one is 2 power 2, third one is 2 power 3, so on up to a value that is 2 raised to the power small n, where n can have any value, positive value in fact, an integer value you can say. So starting with the base case, that is n equals to 1. Now let's see whether the given formula, the given statement holds for this base case or not. Putting n equals to 1 means that I'm going to have only the first term, because the pattern of the series is in fact the summation of 2 power n. So 2 power 1 is going to be equals to 2 on the left hand side. Now coming to the right hand side, this is going to be 2 times 2 power 1, that is putting small n 1 here, minus 1. This is going to result in 2 times 2 power 1 is 2, so 2 minus 1 is 1. So left hand side is equivalent to the right hand side, and it holds for the base case. Now second one is the induction step. And induction step starts with an assumption that we are going to assume that the given predicate, this given predicate P of n, or this given proposition is basically true, right? So let's write it here, that assume for the purpose of induction, for the purpose of induction, that P of n is true, right? So we are assuming that whatever is given to us, that is in fact true. And what is again P of n? The given statement, right? And what we have to strive for, that we have to prove it, we have to show that P of n plus 1 is true, or the formula holds for n equals to n plus 1. Now plugging in n equals to n plus 1 in the given equation, I'm going to have 2 plus 4 plus 8 plus so on up to 2 times n plus 1. And on the right hand side, I'm going to have 2 times 2 raised to the power n plus 1, that is n is replaced by n plus 1 minus 1, right? Okay. Now, elaborating this series, 2 plus 4 plus 8, so on, the last term or one term ahead, that is in fact 2 power n plus 1. And the very previous term is definitely going to be 2 power n. And the same thing here, that is 2 power n times 2. I can break this up, minus 1, right? Okay, now let me erase it. Okay, ji. Moving on to the next step, what we are going to have from the assumption, right, that we have assumed that the given predicate is true. So let me write it again here, 4 plus 8, so on up to 2 power n plus 2 power n plus 1 is equals to 2 times 2 power n plus 1 minus 1, right? And this whole thing that we assumed is in fact equals to, that is true, और जो given हमारे पास equation थी उसे accordingly किसके equal था, 2 times 2 power n minus 1 plus the last prevailing term, which is 2 power n plus 1, that is 2 times 2 power n plus 1 minus 1. मैं फिलहाल उसको उसी तरह लिख रही हूँ, ठीक. Now just simplifying it, that is 2 times 2 power n minus 2 plus 2 power n times 2. इस n plus 1 को मैंने ओपन करके लिखा है 2 times power n times 2 power 1, that is in fact 2, and keeping it just like this. Now this is going to be you can see here that this is 2 times 2 power n, this is also 2 times 2 power n. The same terms are adding here, right? So after adding these two terms, I'm going to get 4 times 2 power n minus 2, right? So upon taking 2 common here, you can say that this is going to be 2 times 2 power n minus 1. I hope you all agree with it and you are understanding it. I have done a very simple mathematics here. 2 times 2 power n, 2 times 2 power n, दोनों को मैंने add up किया है, तो मेरे पास आ गया 4 times 2 power n. It is adding 2 plus 2. So again you can say that this term, that is 2 times 2 power n, बेसिस सेम है तो पावर्स क्या होंगी, ऐड हो जाएंगी. तो यहाँ पर क्या आ जाएगा, n plus 1 and minus 1. That is exactly the same that we had on the right hand side. So finally, sorry, let me erase it. Left hand side is equals to right hand side. So we have proved that E of n plus 1 is true. End of it, right? You can also do another technique here. Uh, I'm talking about this step. You can take 2 common. So this is going to be 2 power n minus 1 plus 2 power n. ऐसा ही होगा ना, अगर आप इस पूरी इक्वेशंस में से 2 कॉमन ले लेते हैं. सो दिस इज ऑल्सो इक्वल्स टू 2 पावर n प्लस 2 पावर n हो रहा है, तो क्या हो जाएगा 2 टाइम्स 2 पावर n माइनस 1, एंड दैट इज इन फैक्ट 2 टाइम्स, अगेन सेम वही फॉर्म आ गई है. तो 2 power n plus 1 minus 1, right? So another way of doing that is this, that we are going to take 2 common. Okay, Ji, let's solve another question here. The question is 1 raised to the power 3 plus 2 to the cube plus 3 to the cube plus n to the cube is n times n plus 1 divided by 2 whole square, right? Okay, Ji. Starting with the base case, where we have to take n equals to 1, right? So starting with the base case with that is n equals to 1, and 1 to the cube is in fact 1, and here 1 times 1 plus 1 divided by 2, I'm plugging n equals to 1 here, right? And we have to take the whole square of it. This turns out to be 1 times 2 divided by 2 whole square. These terms are going to cancel each other, and what I'm left here is basically 1 square. That is in fact 1. So the condition holds for the base case. Now coming to the inductive step, where we have to carry out some assumption. So assume, for the purpose of induction, that the given predicate P of n is true, and we have to show that P of n plus 1 is true. That is, the same predicate is going to hold for n equals to n plus 1. Again, following the same steps, 1 to the cube plus 2 to the cube plus 3 to the cube, so on up to n to the cube is n times n plus 1 divided by 2 whole square. Putting n equals to n plus 1, 1 plus 2 to the cube plus 3 to the cube, so on up to n cube plus n plus 1 cube. I hope you are very well understanding it. I have written the very previous term along with the term for which we are going to prove, that is n equals to n plus 1. Doing the same practice on the right hand side and replacing n with n plus 1. So n plus 1 here within the brackets, we have n plus 1 plus 1 divided by 2 and whole square, right? So what we assumed was that this whole thing, which was according to our assumption, that is our predicate P of n, and that is equals to n times n plus 1 divided by 2 whole square, right? So I'm going to replace the whole series with this value, and then I'm going to solve it further. Let me first erase it, and then we are going to proceed further. So I'm continuing with the last step here. Okay, what I have to write here is that according to the assumption, this is n times n plus 1 divided by 2 whole square plus n plus 1 cube, that was the last prevailing term, right, equals to n plus 1 times n plus 1 plus 1 whole divided by 2 and whole square here, right? So let me first take the LCM on both sides, and definitely okay, let me write it in a more simplified form so that people can understand it very well without any ambiguity, right? I'm taking the square of the numerator and the denominator separately. What I'm going to have at the denominator, that is basically 2 square, तो यहाँ पे क्या आ जाएगा 4 plus n plus 1 cube, and same is the case here, n plus 1 times n plus 2 whole square divided by 4. I hope यहाँ तक clear होगा. Okay जी, upon taking the LCM, that is multiplying and dividing the whole both sides by 4, ये cancel out हो जाएगा and 4 will be multiplied here. ऐसा ही है ना? Now let's move forward. What I am left with is that n times n plus 1 whole square plus 4 times n plus 1 cube, right? And on the right hand side I have n plus 1 times n plus 2 whole square, right? Now moving ahead and opening this area, I'm going to have n square times n plus 1 square. ये सेम ऐसे ही है कि आप लिखें a डॉट b होल स्क्वायर, ये किसके इक्वल होता है a स्क्वायर डॉट b स्क्वायर. So I have used the same concept here. Now plus 4 times n plus 1 cube, and prevailing the same thing that we have on the right hand side. Now taking n plus 1 whole square common, right? What I'm going to have, I'm going to have n square, right? देखिए फर्स्ट टर्म में से मैंने n plus 1 whole square कॉमन लिया तो क्या आ जाएगा डेफिनेटली n square plus 4, ठीक. अब देखिए यहाँ पे क्या था n plus 1 क्यूब था, ठीक है, उसमें से मैंने n plus 1 स्क्वायर कॉमन ले लिया तो मेरे पास क्या रह जाएगा n plus 1, simple. And same thing is on the right hand side. Okay जी, doing some mathematics upon it, especially within the square brackets, this is n square plus 4n plus 4. So n plus 1 whole square times, you can see very well that this is n square plus 2 times n times 2. 4n को मैं ऐसे लिख सकती हूँ ना, प्लस जो लास्ट वाला 4 है इसको मैं लिख सकती हूँ 2 square. So in fact I have employed the concept of completing squares. ठीक, I'm going to carry out it here. So from this step we are going to start from, right? ओके जी, तो यहाँ पे क्या आ जाएगा, n प्लस वन होल स्क्वायर टाइम्स, अब देखिए ये कंप्लीटिंग स्क्वायर से, यानी n स्क्वायर टू, वो चीज़ आ गई आपके पास. लेट मी राइट इट हियर, पीपल वेरी वेल know this formula. A plus b whole square is a square plus 2ab plus b square, right? So this is our a, this is a, this is b, and this one is also b. ठीक, तो मेरे पास सेम वही फॉर्मूला आ गया, n स्क्वायर प्लस टू n टाइम्स टू प्लस टू स्क्वायर. ठीक, तो ये किसके इक्वल हो गया, a प्लस बी होल स्क्वायर के. तो a मेरा क्या है, n है, b को मैंने किसके इक्वेट किया हुआ है, 2 के, तो ये n प्लस टू का इनफैक्ट होल स्क्वायर है. एंड व्हाट वी हैड ऑन द राइट हैंड साइड इज n प्लस वन टाइम्स n प्लस टू होल स्क्वायर. ठीक, so this is in fact n plus 1 square times n plus 2 square, and I can also do the same practice here. This is a times b whole square, तो ये किसके इक्वल होगा, a का स्क्वायर यानी n plus 1 का स्क्वायर टाइम्स n plus 2 का स्क्वायर. ठीक, so this comes to the point that left hand side is equals to right hand side, right? And we have proved that n plus 1 is true. So end of the proof, right? Okay, ji. Now let's do another question here. Say we have a series 3 plus 7 plus 11 time plus 4 and minus 1 is equals to n times 2n plus 1. Okay? For n greater than or equals to 1. Right? Okay. Again, following the same steps and starting with the base case. That is for n equals to 1. क्योंकि हमें यहाँ पे जो लोअर लिमिट दी गई है वो क्या है, n equals to greater than or equals to 1 है. So starting with the base case, in fact जो फर्स्ट टर्म की हम बात कर रहे हैं, या आप यूँ समझ सकते हैं कि इस सीरीज की हर टर्म, चाहे वो 3 है, 7 है या 11 है, वो बेसिकली इस जनरलाइज्ड फॉर्मूला से रिप्रेजेंट हो रही है, यानी कि 4 टाइम्स n माइनस 1 से. ठीक है ना, तो हम पहली टर्म से स्टार्ट करें और पहली टर्म की वैल्यू हमें गिवन है और वो क्या है, 3 है. ठीक, यानी आपको समझिए कि इस पूरी सीरीज में विद n इक्वल्स टू 1, क्योंकि मैं बेस केस से स्टार्ट कर रही हूँ ना, जहाँ से आप आपकी सीरीज बिल्ड होना शुरू हो रही है. तो और अगर आप इसको वेरीफाई करना चाहें तो यहाँ से भी आप वेरीफाई कर सकते हैं कि यहाँ पे जब आप n को 1 प्लग इन करेंगे तो 4 टाइम्स 1 इज 4 माइनस 1 विच टर्न्स आउट टू बी 3. So I'm talking about the first term. On the right hand side we have 1 here, that is putting n equals to 1, 2 times 1 plus 1. So this is in fact 1 times 2 plus 1, which is in fact 3. So base case holds here, which is for n equals to 1. Now inductive step. Okay, this time I am also following the second method जो मैंने last lecture में बताया था, कि एक तो possibility है कि आप n को n ही रहने दें, या दूसरा ये था कि आप n को रिप्लेस कर दें k से और फिर उसके लिए सॉल्व करें. सो लेट मी ऑल्सो शो दिस टू यू डेट अगर आप वो चीज़ फॉलो करना चाहते हैं तो उसमें क्या होगा, कोई चेंज नहीं आएगा प्रोसीजर के अंदर, ईच एंड एवरी थिंग इज गोइंग टू रिमेन द सेम. जस्ट आप वेरिएबल चेंज करें, एन को रिप्लेस करें के से। मे बी आपको बुक में भी शायद यही पैटर्न मिलेगा। सो इन द इंडक्टिव स्टेप, assume for the purpose of induction that predicate P of n is true, right? So we let n equals to k and assume that P of k is true. Okay? And what we have to show? We have to show that अगर P of k true है, then it also holds for P k plus 1 is true. Okay, ji. Now starting just replacing n with k. What series I'm going to get here is 3 plus 7 plus 11, so on up to 4k minus 1. On the right hand side, I'm going to have k times 2k plus 1. ठीक, और डेफिनेटली मैं यहाँ पे ये भी लिख सकती हूँ कि k greater than or equals to 1. Now putting k equals k plus 1. जिस तरह से पहले हम क्या कर रहे थे, n को कैसे रिप्लेस कर रहे थे, n plus 1 से. So let n, sorry, I should write it ting n equals to k plus 1, क्योंकि पहले हमने n को equals to k किया, अब हम n equals to k plus 1 कर रहे हैं. So the series I'm going to get is 3 plus 7 plus 11, so on up to 4 times n की जगह क्या आ गया, k plus 1. So k plus 1 minus 1. ठीक, and on the right hand side replacing every n with k plus 1, 2 times k plus 1 plus 1. ठीक, okay जी. Rewriting it here, 3 plus 7 plus 11, so on up to, again making use of the very previous term, that is 4k minus 1, और इसकी वेरी नेक्स्ट टर्म क्या होगी, क्योंकि हमने k प्लस 1 की थी, तो k प्लस 1 माइनस 1, दिस इज इक्वल्स टू k प्लस 1 टाइम्स 2k प्लस 1 प्लस 1. ठीक, and this was the predicate that we assumed, और ये किसके इक्वल था, P of k according to our assumption. So this being true, that is in fact equals to k times 2k plus 1 plus the last term here, that is 4 times k plus 1 minus 1. This is k plus 1 times 2k plus 1 plus 1. Okay, okay ji. Now solving it, the simplifying it in fact, this is going to be 2k square plus k plus 4k plus 4 minus 1. And also simplifying a bit on the right hand side, this is going to be 2k plus 2 plus 1, right? So this is going to be 2k square plus k plus 4k plus 3. And on the right hand side, k plus 1 times 2k प्लस 3. ठीक. अच्छा जी, इसको अगर हम थोड़ा सा और सिंप्लीफाई करें, इनफैक्ट कंबाइनिंग दीज टू टर्म्स, so this turns out to be 2k square plus 5k plus 3. So k plus 1 times 2k plus 3. Okay ji, now completing squares, this is going to be 2k square plus 3k plus 2k plus 3, and same thing here. Okay, upon taking k common, what I'm going to get here is 2k plus 3. ऐसे ही है ना, यहाँ पे अगर आप k कॉमन लेते हैं और अगर आप यहाँ पे 1 कॉमन लेते हैं तो गेन आपके पास ये 2k plus 3, यानी मैं इस टर्म की बात कर रही हूँ, इसको मैंने एक तरह से कलेक्टिवली सिंगल टर्म लिया यहाँ पर, वो आ जाएगा. एंड वी आर गोइंग टू हैव the same thing on the right hand side. So this turns out to be 2k plus 3 times k plus 1. Very simple mathematics that I have applied here, that you people have done dozens of times in FSC. So what we get at the end is left hand side is equivalent to the right hand side, which shows that P for k plus 1 is true, bringing me to the end of the proof, right? So these are some key steps that we have to follow while making use of induction method, how to prove certain statements. Do have a very good practice of it and thoroughly go through the lecture. And if you people have any queries, we are definitely going to discuss them in the interactive session. Thank you.